it's a lot easier to request it, right? Okay, so today, which is nice, I'll tell you, I'm glad your book put section 8.5 in here because it's going to turn into a nice review for the test actually. So I'm glad that they added it. 8.5 is really just about deciding which one of these to do because on the test I'm not going to tell you, hey, use the Z interval or hey, use the T interval or right. So you have to know which one to do, and that's really what 8.5 is about. It's about choosing which path. And if you open up your book, you'll see. Let's switch over. I'll switch over the document camera now. You'll see on page 407, it gives a nice little path to what's going on. I'll see if I can just plop it on there. Yeah. Let's see. Zoom in, which means I'm just putting it lower to the book. Look, remember this is population standard deviation. If we know it, and our n is greater than 30, just use the Z method, right? Mm-hmm. If n's not greater than 30, but we know it comes from a population that's approximately normal, use the Z distribution. Notice everything above here is Z distribution. Everything below is T distribution, okay? If we don't know the sigma, we have to use the T distribution, the T method, okay, that we went over yesterday. And that's I mean, we know that already. It's just summing that up for us, and I like that your book did this because again on the test, so this kind of turns into really just a test review. A good test review question is like example 8.2. So sample 8.21 or this example 8.21, which is on page 407. It says, look, we've got a random sample of 41 pumpkins from a pumpkin patch, has a mean weight of 8.53 pounds with a sample standard deviation. That's what we had to notice, a sample standard deviation of 1.32 pounds. Construct a 95% confidence interval. That's what it's wanting. For the mean weight. So notice it gives us sample standard deviation. So because it's sample, we can't use the Z distribution. We have to use the T distribution, right? So if I want this 95% confidence interval, go to my calculator because it's going to make my life a lot easier. And I'm going to go, now we know the stats. We don't know the data, right? So we're going to do stat test. And this is going to be T interval, right? Now it's a T interval because it's a sample standard deviation and not the population standard deviation. And again, we know the stats. So I'm going to click stats. We've done this one, right? This is just a review. Yeah. How to pop these in. So 8.53, sample standard deviation is 1.32, N is 41, and they want 0.95. 8.11 to 8.95 if we round it. Okay. And remember, the follow-up to that is we're 95% confident that the population mean of pumpkin weight for this area, this pumpkin patch, is between 8.11 and 8.95 pounds. Okay. So the idea behind this section is knowing, hey, I'm supposed to use T interval. Where let's see if the next one is. Oh, they just give you one example. Let's look at one. Let's look at a different one. It's only giving us S. Hold on. Oh, here we go. Like number, well, say that. There's a lot without S there. Let's do one more with proportion. So this is just going to turn into a nice review. Number 6 on your homework, page 408. Actually, I lied, guys. I lied. Number 2. Let's do number 2 first. Number 2, which is still on page 408. It says a simple random sample of size 80, so n equals 80, has a mean of 7.31. The population standard deviation, it's given us the population standard deviation, so we're going to use the Z distribution here, is 6.26. Construct a 99% confidence interval. Okay, so I'm going to go back over here. I'm going to clear this out. I'm going to go to stat again, test. But now we've got a Z interval, right? We've got a Z interval because it's a population standard deviation. T interval went with standard deviation, sample standard deviation. Z interval. Again, we know the stats. We don't know the data. So I'm going to click on that. I've already clicked on it. Sigma 6.26. X bar is 7.31. And N for this one is going to be 80, right?
Mm-hmm.
And they want, now the question was at 99%, so 0.99. Boom, 5.51 to 9.11. Yep. Oh, okay. I'm going to have to chop up the question because remember I didn't do 8.4, which was finding like the standard deviation, the confidence interval of standard deviation. That's fine. When I do this homework, I'll only choose the ones that we've been looking at. Okay, so it won't be a big deal. But again, we're 99% confident that the population mean is between 5.51 and 9.11. Okay, there's no units for this one. No, it doesn't give us a unit or anything like that. Okay, and this is just a really good this is a really good review. Okay, really good review, and I'm glad they did this one. Okay, I'm trying to look at even ones. Okay, let's try to do 16. Okay, 16 says we got credit card debt, right? Yeah. In a survey of 1,118 U.S. adults conducted by the Financial Industry Regulatory Authority, 626 said they always pay their credit card bills in full each month. Construct a 95% confidence interval for the proportion. So now we're dealing with proportions. I'm just going to write that down. Proportions. Construct a 95% confidence interval for the proportion of U.S. adults who pay their credit card bills in full each month. Okay, so we're dealing with proportions now. It didn't give us a standard deviation, right? It didn't give us a population or a sample standard deviation. Got to remember what buttons to press for proportion. So stat, I think it was A, wasn't it? Yeah, one proportion Z test. So remember we go to stat, test, and then all the way down to A.
The T interval?
Yeah. Well, no, it's not an interval. It's one dash.
Oh, A.
Yep, A, not 8. Yeah. 1 prop 2 int. So now remember, X is the number that we found. We found that 626 of these consumers paid their bill off in full, and 1,118, holy cow, were surveyed, and they want a 95% confidence interval. Boom, there it is. Now, the proportion would be 0.531 and 0.589. Okay?
Okay, so what the N you would have N as what?
Oh, N is the number that were surveyed. Remember, 1,118 were surveyed, right?
Okay.
Yeah.
I don't know why I didn't see that.
Oh, it's okay.
It's Wednesday, I guess.
Yes, blame it on Wednesday. Okay, now remember, I'm going to throw something else in here just for a good review question. What if someone stated, is it appropriate to state that more than half of consumers pay off their credit card bill each month. Could you say that was a true statement? What do you think,
Yes.
Laura? Yeah. Yeah, because the average, it's, we're
0.5.
saying, huh?
Because 0.5 is half and 0.531 is over half.
Bingo, bango, right? We're saying, look, we're 95% confident that the actual proportion is between 0.531 and 0.589, right? So that means we're at least 95% confident that the average is above 50%, right? Or the proportion, I should say, is above 50%. Okay, those are good follow-up questions to these. And I'll tell you, the follow-up questions, look, let's say you got one wrong. I'll have to make up like a new question for a follow-up question, just in case. So it would be like, hey, if I got this interval for the proportion for the last, for a question, could I assume this? And it's a good open response. Well, why or why not? Okay.
Okay.
Makes sense?
Nope, that looks pretty easy.
Yeah, it's not that bad. It is not that bad. Okay. So for homework, and we'll get into a review. So for homework, I would treat this homework like a good review for the test. Okay. It would be a really good, there is some stuff that, we talked about that's not in here, but it is a really good review for the test. Now I'm going to get very, very, very specific. Actually, what I'm going to do is tell you the ones not to do. So I want you to do, huh?
The ones not to do?
Yeah, because we didn't go over confidence intervals of the standard deviation, and it has that in here. So I'm going to tell you the ones not to do. So I want you to do all odds except, okay, I know that's goofy, but just trust me here. Except 1, 7, 15, 1, 7, and 15. So it's only 1 through 19. Okay, it's not that many. 1 through 19, but do not do 1, 7, and 15. Okay, so 1 through 19 odd, except these. Now it's on page 408
to 409.
Yeah, 408 to 409. Okay, and I'll tell you, this is just a really good review. 4, 8, 1, 2, and 3. Okay. So good. We can start. Now, Laura, did you have any questions? I didn't ask you that. Did you have any questions from the homework?
From the other homework?
Yeah.
Well, I went back to 8.1.
Okay.
And I got stuck on number 6.
Okay. Let me do a review, and then I'll go over it with the review. It'll work well with it. Okay.
Yeah.
So in section 8.1, let's start there. In 8.1, the goal here was, hold on a second. Oh yeah, this is when we knew the sample or the population standard deviation. So 8.1 is when we knew the population standard deviation. So we use the Z interval because the sigma was known, right? The sigma was known. So there are a few things I need you to know definition-wise that'll probably pop up. The point estimate. Point estimate, not worry about critical value or standard error. And then the definitions of confidence interval and confidence level. Confidence interval and level. They're on the next page. They're on page 360. Okay. There's not going to be much definitions on this one. There is going to be great interpretation questions, but there's not going to be a lot of definitions. And the goal of this section, and we use the calculator, was to find confidence intervals when we knew the population standard deviation, right? And that's what we did. I used the book goes more over how to use a chart, how to do other stuff, but we used the calculator. Okay, you said number 6.
Yeah. I could do some certain things, and then I get to one, go totally.
No, that's fine. So you said 8.1, right? Okay, so this is on page 364, and it says, in a survey of simple random sample of students at a certain college, the sample mean time per week spent watching TV was 18.3 hours, and the margin of error for the confidence. Yeah, I'm not worried about that one. You can just make that one go away from your brain. Worry.
Okay, good.
Yeah, so don't worry about. Does it? Yeah, because it doesn't give you the sample standard. No, don't worry about that. Don't worry about really 6, 7, or 8, because I'm going to give you like what we've been doing so far, where I give you the data or I give you the stats, and you have to put it in the calculator.
Okay, cool.
So a better example for this, I'll just make up an example. Let's say they found that 18.3 hours was the average of this sample. We had a sample size of, let's say, 120 students. And we also found the population, or we know the population standard deviation is, let's say, 11.5. And I want a 95% confidence interval. Okay. Now look, and here's the thing, because we know the population standard deviation, we have to use the Z interval. Oop, I clicked the wrong button. Stat tests Z interval, right? Sigma is known, population parameter is known, so we need to use the Z interval. Now we know the stats here. I'll do one with just the data here in a minute. So we know the stats, and we know that sigma is 11.5. And it even kind of tells you, the calculator kind of lets you, I'm not going to say cheat, but it tells, the sigma's right there, right? And it says S for the other one. 18.3 is our average, our mean, and our N was 120, and we still have the right interval in there. So this would be 16 point, let's say 24, we're around to 2 decimal places. 20.36. And I'm going to tell you, the answer I put on your Blackboard test is going to be from the calculator. So if you do this correctly in the calculator, you'll get the same answers. Okay.
Okay, cool.
You'll get the same answers. You don't have to worry about rounding it correctly and things of that nature. Excuse me. So look, let's say I give you this information and I ask you to interpret what this means. Okay. Here's what I'm looking for. This is the open response step. We are 95% confident the population mean of hours spent watching TV. I think it was like for college students.
Yeah, I think so. I don't know if it's college or just students.
Yeah, each week is between 16.24 and 20.36 hours. I know I said hours twice, but that's fine. 16.24 and 20.36 hours. So we are 95% confident the population mean of hours spent watching TV for college students each week is between 16.24 and 20.36 hours. And I know you might think, but I only watch like 5 hours. That's fine. We're not talking about how much you watch. We're talking about what the population mean would be, right? Because there's other people that watch like 50 hours a week, which is crazy.
That would be about me. I'm always watching TV.
great example. So a great example to find the interval, and also a great example of interpretation. Okay, great example of finding an interval, and also a great example of finding the interpretation. But okay, another example from 8.1 is if you have the data. Okay, so if we knew the data, let's say, we have a set of data. Let's say we actually go out and sample these students, and we've got, one student says they watch it, 15 hours, and another, we make them round to like, the hour. Let's say 14, and another says 20, and then 17, and then 30, and then 8, and then 16, another 17, 18, and 15. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 of these students, and hold on, let me see how these are asked in the homework. Yeah, we have to assume the standard deviation here. The assumed standard deviation is going to be, what was it before? 11.5. Let's say it's actually 7.9 for some reason here. I don't know why. I'm making this up. So again, we asked college students about their viewing habits, and we want to know their, we want to know from the data now, or from the list. So first off, we've got to make a list. Remember, it was stat edit, and I'm going to make this list 1. Delete. Oh, wait, how do I add in there? Apparently, I'm going to make it list 4. Okay, I'm going to make, can I change that? Hold on. Nope. Yeah, that's weird. Uh-oh. Huh. Okay, well, I don't want
Hit delete.
Hit delete.
Yeah, if you want to delete, now go up, delete.
Sorry, delete. Okay.
There you go.
Yeah, well, I've got to make it list 4. Okay. So list 4, and I'm going to do 15. I got to make sure all these are right. 15, 14, 20, 17, 30, 8, 16, 17, 18, and 15. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10.
Mm-hmm.
And now I'm going to go back to stat, tests. It's still the Z interval, right? But now I've got data. Yeah. And now my sigma is going to be 7.9 because I have to give you the assumed population standard deviation for this question. My list, though, I believe it was list 4 for me because I deleted all the lists. I got to figure out how to get those lists back. And let's say we want, again, 95% confidence. So calculate. Boom. 12.10. Make sure you get the same thing, Lori. 21.90 when you round.
5.5. Okay, 12.10 and 21.90.
Perfect. That's what I got. So again, if we're going to interpret, I'm 95% confident that the average hours of college students TV viewing each week, the population mean, is between 12.10 and 21.90 hours. Okay.
Mm-hmm.
So those are 2 ways it can be asked. But now what's important when you're reading the question is, does it give you the population standard deviation? If it gives you the population standard deviation, that Z interval is what we're going to use. Okay. Now let's go to 8.2. Make sure I didn't miss anything. 8.1. No. I mean, all of the, I'm going to just tell you, all the homework I gave you is what you need to be looking at, okay, except for penalties. But 8.2, 8.2 is different because you're going to be given the sample standard deviation. I got to get some more markers. Okay, sample standard deviation. So, not worried about the stuff in the book. So, what I'm going to ask you is really like the stuff we talked about. I'll tell you that the questions from 8.5 are, just consider that your review, your study guide. Okay, but let's look at 8.2, and I'll steal one from 8.2. This is number 22. It says general social survey asked 1,972 adults how many years of education they had. The sample mean was 13.37 with a standard deviation. Oh, no, so it's a sample mean and a sample. It doesn't say population standard deviation, so we have to assume it's a sample standard deviation. 3.13. I'll tell you on the test, I will be straightforward. I will say sample standard deviation and a sample mean of, and give that to you. Okay. It wants for A, it wants a 98% confidence interval.
What number are we doing?
22 on page 385.
Okay.
So now this one's different. Now we've got a sample standard deviation. We're not going to use the Z distribution. Now we have stats. We don't have the data. So I'm going to go back to my distributions. I hit the wrong button again. Go to tests. And now we're going to use the T interval, right? We're using the T interval because it's a sample standard deviation. And we're going to use the stats because that's what we're given. We know X bar is 13.37. We know S is 3.13. N is 1,972. And our confidence level is actually 1.98%. 13.21 to 13.53. 13.21 to 13.53. Okay. So we're 98% confident that the sample standard deviation, we're 98% confident that the population mean for years of education for adults is between 13.21 and 13.53. And that's, I might ask you with the data. I might ask you with actual, the data set, right? But it's the same thing. It's knowing when to use the Z or the T, okay?
Uh-huh.
And then 8.3 was on proportions, which we already did an example of. So a proportion question is not going to give you the sample standard deviation or any standard deviation. It's going to tell you, remember that credit card example we did earlier, right? Mm-hmm. It's going to say, hey, we got 1,118 users and 620, do a certain thing. So that's when you know it's a proportion. And I will make sure to say proportion in the question. So if we looked at, let me steal one from the book, just a good example. Yeah, like number 26. We've got a sample of this is on page 399, number 26. And a sample of 42 water specimens taken from a construction site, 26 contain detectable levels of lead. Construct a 90% confidence interval. So 90%. For the proportion of water specimens that contain detectable levels. Now, remember, X is our amount that were detected for this one. So 26 out of our N, which is 42. But it says clearly proportions in the question, right? For the proportion of water specimens. So that's the indicator for this one, is it will say proportions, okay? So stat. test. Now for this one, we've got to go down to A, right? For one proportion Z test. And our X value is 26. That's how many that had the lead. 42 is how many we sampled, and they wanted 90%. So 0.456 to 0.742 if we round to 3 decimal places.
Okay, did you do the T interval or the Z?
No. This is proportion.
Oh,
You got to keep scrolling down. We're going to use the one.
I knew that.
Yeah, it's A, right? Whatever A is. I forget what
I
it's
knew
called.
that.
Oh, one proportion Z interval. One proportion Z interval.
Which is A. Okay, gotcha.
It's A, yeah.
No, 42.
Now, so let's say, could we interpret this? Could we say that, you're some company that doesn't want lead in their water, right? And they come along and say, well, it's reasonable to say that less than 30% of the specimens have lead. Is that a true statement? Can we say that's a truthful statement based on the evidence?
Okay, how'd you come up with 456?
Oh, it's 495. Good Lord. Or 496, right?
Yeah. See,
496.
you're trying to confuse me.
I am. I'm trying to confuse myself sometimes. 496.
42. There we go. You just didn't want the 9 in there.
That's true. So could we say that there's less than 30% of specimens with lead? Using a 90% confidence. With 90% confidence, I should say like that. With 90% confidence, can we say less than 30% have lead? Lori, what do you think?
No.
No, we know it's between
Between.
0.496 and 0.7574. That's a lot, right?
Yeah.
There's no way we could say that. Okay, that's a good question from 8.3. Now we might have you wouldn't use data and proportions because you would just know that. I mean, this is a really good review. So it's really about interpreting it with like, oh, we're 90% confident that the actual proportion of specimens is between these two numbers. And also, could we assume with 90% confidence, that half have lead? Well, yeah, we can, because 0.50 is between there. Okay. So that's another good way to ask that question. Another good way to ask that question. Okay, so for review, I would use the 8.5 section. I would use the 8.5 section for review. And then go back and look at homework from 8, 1, 2, and 3.